And here we go. So for this one, 6.3, measuring spread. There is one term that I think for all students, even methods students, I still have to explain. So you guys, I'm going to give you a sort of synopsis of what it actually is. But overall, today's measure or today's understanding is to understand the measure of spread. How does it affect your data? And what are you interpreting from that? Okay. Now, measure of spread describes how far the data is. How far the data is, or how close the data is to each other. Okay. Now, we can measure it by finding three key things. Now, out of those three, this one is the one I think a lot of students will not understand. And for you guys, Year 12s, the standard deviation, you don't need to do it by hand. Your exercises will get you to do it by hand. Or you could use a technology like Excel. And if you have a CAS calculator, you can also do that too. But part of the foundation course, it's expected that you're going to do it through technology. But what do you need to know? For Year 12s, you do need to know the essence of what standard deviation is, like the idea. So unlike methods and special, they actually calculate it and derive where the formula comes from. You guys don't need that. You guys do need to understand what it generally means. For the Year 11s, you just need to know that it is part of the three calculations, but not until Year 12 that you kind of see the process to it. Okay, so since you're in this class, you'll kind of see the process anyway. So we got one of the three key measures of spread. You got your easiest one, which is range. Now, how do we calculate range again? Can I please have Archie? How do we calculate range again? What was the formula? Highest number minus lowest. Okay, so if you want to know what range of data you have, you take the maximum score you got, subtract the lowest score, that is the range you're working with. What's nice about the range, you get a general feel, but it doesn't really give you much accuracy of the data. Okay, so I'm going to write here, general feel, not much detail. Okay, so that's the logic. So then they said, all right. And also, the range is a problem as well. If you have someone in your class that is an extreme either end, either they're super academic or they're super unengaged, then it also skews the range. So if you had most of your students, let's say in the class was like 20, 25, 30, and then you get one student who's getting 100, then your range now, instead of it being between 20 and 30, your range now is affected by an outlier, which is why range is not always the best, but it gives you a general feel. But in terms of detail, we prefer interquartile range. What was the formula to find the interquartile range again? Let's go on this side now. Let's go with Estella. How do you find IQR again? Good. Q3 minus Q1 for those who've forgotten. This is the 75th percentile. So if you rank people from smallest to largest, the person who's standing in the 75th position, subtract the person who's standing at the 25th position. That gives you 50% of the data, but it's the 50% of the general population. It's not 50% of the bottom half. It's not 50% of the upper half. It's the actual 50% of the middle group. That's what that is. Okay, so for those who forgot why IQR is important, it's 50% of the middle group. That's why it's special. Why is that also special? It means that if you had extremes, even in a class that I just described before, even you have someone who's getting 100 and everyone else is getting 20 to 30, IQR, we ignore that. It doesn't affect IQR because you're not looking at the extremes. So this is great for non-extremes. This one's terrible for extremes. Okay? Then your last one. So it seems like number 1, number 2 is pretty good enough. And that is true for Year 11s. That's mainly what you need to know. Year 12s, you do need to know, well, what is standard deviation? In today's lesson, I'm going to try to give you an understanding of it. That's the main part of today's lesson. And then there's cumulative frequency, which I'll show you how to use. That's pretty straightforward on how to do. Okay? Just one extra bit for part of your notes. These 2 bits here to fill in. So what is standard deviation? Is the measure of spread of the data about the, and fill this in, the mean. I'll explain what that means later, and then it makes a lot more sense what that line actually means. This formula in your exercise book, yes, you do need to know how to use it. In the exam, you won't. In the exam, they'll probably give you a table and you fill it out, or there might not even be in the exam. You just need to know the essence of it, okay? So I'll explain what this is soon. What's that arrow? I'm just saying this is the population. I'll just call it population for now, okay? All right. This, however, you do need to know there will be an exercise where you focus on outliers. Anyone remember the formula from this? So general students would have seen this, and maybe those who did year 10 last year would know. Yes. Beautiful. And do you know the next one? Beautiful. Now, for those who don't actually understand what this formula is, if you really think about it, where's the logic? Where's this formula coming from? So we said IQR is 50% of the middle group, right? So if you think about it, if this is where everyone sits in a box plot, right? So maximum, minimum. If this is where everyone sits, and this person here is the 25th percent, so they're the middle of the lower half. So if you went and said, all right, let's split the class, the bottom half, who doesn't really do too well, less than 50%, and the upper half is on this side. Then you go, all right, in the group that's very low, you say, who's the middle of the very low group? Then people are like, oh, him. So then he stands here, right? That's the 25th percentile. That's your Q1. Now, what's interesting is, what are we doing here? We're saying subtract. So whoever's sitting at the 25th percentile, they're not the last person, but you're subtracting. So you're getting a worse score. You're subtracting this direction by 1.5. Now, those who don't know that percentages, that's 150%. That's saying, take your 50, this group, this is IQR, take this group, whatever that range is, times it by 150%. So inflate it. Take the general population, inflate that by 150% in that direction. That's what that's saying. See, that's saying, take that middle person, go further by 150% of the IQR, which is the general population. And if that is the lower fence, anyone who gets worse than that means that you're worse than 150% of the general population. Does that make sense? That's why we do that. And the same thing on the upper end. See, on the upper end, why is it Q3 plus? Is because you're saying, what if someone scores more than 150% of what the general population is? If your general group is here, and this person is scoring not just 100% better, but 150% more, this person has to be really different from everyone else. That's why we say it's plus 150% times the general population. That's where the formula is coming from. That's the standard that we do in statistics, that we say if you are scoring 1.5, which is 150% more than someone, you're very different from that person. You're not technically double. You could be double, but 1.5 is significant. That's huge. So that's why anyone who passes that lower fence or upper fence, so on the low end or the high end, we consider that as an outlier. It means that you're not really part of the data. You're on a separate data. You should be analyzed with someone else. Okay, that's the idea. All right. Now that we've got our notes, let's flip over to the side over here. Can you flip over the back page? I'm going to try to explain what standard deviation is, but not towards what, say, the methods and the special group needs to understand. For you guys, standard deviation, think of it this way. Those who want to do exams, ATER scores at the end of the year, do you guys know what the maximum study score is, roughly? 50. And what is the middle score? No, 30. 30 is the average. Okay, so this is what it looks like. 50 is the very end. Everyone who scores the average or middle is 30. That's your study score. That's raw. Okay, so this is raw score. Now, let's say in a scenario, in this class, after this year, I've done all your tests, I've done your SACs, I've looked at your homework, and I asked the number of hours you studied per week. Okay? And then I have to predict what you get on the exam. So on that end of year exam, if you do an exam, I have to predict for you. Let's say this is my prediction. I had a formula. I'm so smart, I come up with a prediction, a formula that works out the number of hours you study. I can predict your percentage. Okay, imagine that. Say this line is my prediction. It's the average goal that I think that you're going to get. Let's say, if I said, according to my formula, if you studied 10 hours every week for foundation, you'll get really close to 100%. Let's say you get 99. Okay, I'll just make it 90, round it off just to make it easier. 90%. Okay, and if you studied half an hour, you get closer to 50%. Let's say, it's my formula, right? I want you to logically think about this. What if I told you that at the end of a year, this is what you actually get? You studied 10 hours and you end up getting 100%. Okay, so that's your data. You studied, so one of my students studied 10 hours in that week and they got 100% for the exam. Am I 100% correct or am I off? How much am I off by? 10%. So I'm off. I'm going to write here 10% off. Then let's say another student who studied only half an hour and walked into that exam and they got half an hour and they got 40%. But I predicted they get 50%. How off am I now? Still 10%. But there's a difference between this 10% and that 10%. What's the difference? One's higher, one's lower. So I predicted you'd get 90, you got 100. So you were better than my score. This one, notice here, I predicted you get 50, but you got 10% lower. Now here's the problem. If we calculate it, your score was 100 minus my prediction. 100 minus 90 is still 10. True. Then the next person, they got 40 minus my prediction. So this is always prediction. So I'm going to write here prediction. So this is prediction. And this is your actual score. Can you see 40 minus 50? It's also 10, but it's negative 10. Negative means that I've underquoted you, right? Oh, sorry, I overestimated you. Now, when you find the average, because you want to see how bad my predictions are, if we just found the average of my error, I'm 10% off. If you found the average of this, 10 plus negative 10 divided by 2, because the average is sum of all numbers divided by number of numbers. What's the problem here? What's 10 plus negative 10? 0. But then 0 divided by 2 is 0. That would mean I've got a 0% error. What's the problem with that? What's the problem with saying that my predictions, how good my error, so I'm saying this is 10% error, 10% error, and let's find my average error. And then my average error ends up being, on average, I have 0% error. What does that mean? If I have 0% error, if I told you I have a 0% average error in my predictions, what would you interpret from that? I should get them all right. That's a problem. I'm clearly not getting them all right. I am clearly off. I said we just did a quick random prediction here and I'm already off. Okay, it doesn't make sense. I'm clearly meant to be 10% off. This is why in the formula, we have to square it. See, that one is take your actual score minus my actual score. Okay, so my prediction, so your score minus my prediction. And then what's this symbol? That means sum. Find the average. Add all the numbers together, divided by the number of numbers together. So why do we have to square it? It's because the problem is right here. Do you see that? Minus 10 and plus 10, they're the same number, but they're just different directions. And because if you add them with the different directions, I can get a net 0. That's why they say square. Okay? The rest you don't need to understand, but do you understand that bit that I was just trying to describe there? Okay, so if you have a negative 10 and a plus 10, finding the average of that, that's a problem. That's why the formula works the way they do. Do you need to know the formula? You need to know how to do it for your exercise and how to solve it, which I'll show you how to. But what is standard deviation then? Let's have a look at this picture. See that picture? This line is my prediction. That is the average mean that I think you're going to get. What you actually get in real life, say this one, I'm going to give you a picture that you all can intuitively answer to me. If this is my prediction of what you get, And let's say this is my class. How's my prediction so far? What would you say? Is it good or bad? Roughly good, right? Versus, if I give you this one. If this was my prediction, which one's a better estimate? Number 1 or number 2? Number 1. So you intuitively get it. What you're doing right there is the formula I just gave to you. I just said, so you're looking at this intuitively and you're saying, well, this is where Mr. Tran predicted, but this is too sparse. And what you're actually looking at and you're intuitively doing without realizing is you're looking at how far each of your data is from the mean. That's what standard deviation is. Standard deviation is the measure of how far away from the mean. So let's look at the definition again so that it makes sense to you. See this definition, and when I wrote here, I said measures the spread of the data about the mean. See, what I'm saying there is you intuitively got that just now. Without me even, if I didn't even show you the mathematics to it, you intuitively knew the second one was a bad prediction and the first one was a better prediction. Because what you're intuitively doing in your head was you're doing this. Not accurately, but you were doing that roughly. You're saying like, oh, the data looks too far away from where the line of prediction is. That's why it's inaccurate. Standard deviation, the more spread it is, the more error there is. Why is that not useful? Here's a line that I hope that it kind of sticks with you. Imagine I said this to you. Say you're going to go to the exam. Scenario 1. I say to, let's say Josh. I'm like, Josh, I predict based on all your sacks so far, you're pretty good. I reckon you're going to get a raw 40 plus or minus 2. Versus, if I told him, scenario 2, Josh, I think you're going to get a 40 plus or minus 20. See, the plus or minus 20 is not useful. Why? Because that means he could either get a 20 or get a 60. But we already know the average is 30 or maximum of 50. By me telling him plus or minus 20, even though I gave him a range, doesn't matter. The larger that range is, it's not important to him. But this one, if I told him that I had 0% error in my prediction, every year I get it right. And I said, Josh, I reckon you're going to get 40 plus or minus 2. He's going to walk out of here feeling really confident because he trusts in my prediction because that error is small. That error there is standard deviation in simple terms. Yeah, so in simple terms, it's how far from my prediction. Does that make sense? So in your own notes, can you please write, just to help you understand it, this is your prediction. This is your standard deviation. That's what it is. It's how far away from the mean is. How far from that prediction. The larger the standard deviation, the more variance, meaning there's more options that could happen. Okay, obviously in reality, for me to be this good at prediction, it's very hard. This is a lot easier. I'm more confident this is going to be true than that one because this is a lot harder to do. Yeah? All right, so for those year 11 and 12s, the essence was that. If you got up to this bit and you were listening up to this bit, hopefully that was the essence you took away from standard deviation. So if I asked you what standard deviation was, you know it's different from IQR. It is the measure around the mean. How far are you from the mean or the prediction? The larger that distance is, the more variance there are. And variance is not great. Okay, so if those who didn't really understand that as well, here's another one as a visual aid. Here we go. Let's have a look at this one. So this is a distribution data. We can see that by studying the center, they all have a center. We can see the center is here, center is here is the same one, and the center is the same. So the center is the same for all of them, but it's not the same information. See, what's the difference between each one? This class has a shorter width from where everyone's sitting at. See that width? That width is smaller, it's narrow. You would say that, wow, this class is pretty strong because most of them sit between 80 and 120. This class is average because now you've got kids bleeding into the 50 to maybe 130. Then you look at this one, you're like, oh, yes, same center, but it's so much more spread. You've got so many students on the lower end, so many students on the upper end. This class is strong, not necessarily on score because they're not getting 160, but everyone's getting roughly the same score. That means whatever that program they're following, everyone is improving in the same rate. If I get that data for foundation, that's fantastic. because that means no matter where you're all sitting, my range is very small. That's what standard deviation is. Standard deviation is the measure. It's measuring how far away from the mean you are. That's what it tells you. Okay? All right. Fun fact for you guys. For your study scores, those who want to do exams for VCE, I already told you that the middle is 30. Does anyone know what the next, so they call it one standard deviation, which means one step to the right and one step to the left. Anyone know what the next bracket is? I kind of mentioned it in one of my lessons, very briefly. Ooh, so close. 37. 37, so 7 units up and 7 units down. This here, for those who do methods and maybe general, will learn this as well. 68% of you, so 68% of the students in this class, if I had to make a prediction, you're going to sit between 23 and 37. That's roughly where it is. Okay, so in general, statistics-wise, there's obviously an outlier usually, but 68% of you will score, if you did end of year for year 12, you're going to lie between 23 to 37 unless you're different from 68% of the people in the class. Okay, so that's where you move up. You know when students say they want to get a 40 raw at the end of year? Does anyone know what you have to be in this top end? So we said 68% of you will get 23 to 37 raw. Anyone know to get a 40, what do you need? Oh, close, but much smaller than that. What was that? What was your one? Just a bit smaller than that. Just a bit smidge smaller than that. 7 point. You got to be the top 7.9. So say 8%. You got to be the top 8% of the state to get a 40 raw. Now, this is what I was saying, that if you do foundation in this next few years, I'm saying that you guys have a really good chance, because that's what I'm predicting. I'm saying you just need to be the top 8% of only 2,000 students. That's very doable, because 50% of them are already getting 26% on the exam. I do believe if you train and I train with you, I do believe I can push you in the top 8%. It's really doable. Doesn't matter, but you're still applying the theory. You're understanding it. Okay? All right. All right, team. That's standard deviation. Now let's do a quick calculation for those who are doing it on their exercise book. This is for year 11s as well. Year 11s don't need to know this one. Percentage cumulative frequency. That bit you don't need to know. Feel free to listen in later though. All right. Here we go. Year 12s only. Let's go. All right, year 12s. Eyes and ears towards the board, or at least on your sheet. Example 2. I tried to illustrate on Excel how to calculate your standard deviation. Now, you can use Excel or you can use a calculator for this. Okay? Thanks, boys. I'm just explaining this process. I want you to sort of listen to it. Okay? All right, here we go. Let's say I gave you 4, 6, and 8. This is your data. 4, 6, and 8. If I asked you to find the mean, okay, so we know that the mean is equal to 4 plus 6 plus 8 divided by number of numbers. How many numbers do we have? 3. Very good. If we add them together, 4 plus 6 is 10. 10 plus 8 is 18. 18 divided by 3, which is... How many 3s in 18? 6. Very good. So the mean, so far, if the data is 4, 6, 8, the mean is 6. Here we go. If we were to calculate standard deviation by hand, this is what it looks like. The formula says, take your data minus the prediction, which is the mean. Here's your data, 4. Your prediction is 6. 4, take away 6. It's negative 2. Fill this in. Whereas the second one, 6, take away 6. You get 0. And then lastly, 8 take away 6. So your score, take away what I predict, you also get 2. Now remember I showed you before. Thanks, boys. We'll copy. All right, good. So here we go. So from the data, I found the difference. In the formula, it says that you are going to find the average of my error. So here's my errors. -2 plus 0 plus 2. But the problem is if you do that, it's going to give you 0. That's why the formula says square it. See how it's squared? So here we're going to square each one. -2 squared is 4. Remember, you can do this on a calculator as well. So 0 squared is 0. And 2 squared is 4. 4 plus 0 plus 4 gives you 8. Okay? So far, this gives me 8 as the sum. So what I've calculated here is 8. So I found your score, take away mean, your score, take away mean, your score, take away the mean. Add them all together, so sum of numbers, divide by number of numbers. So number of numbers, I have 3. Okay, so I've got 3. Now, according to this formula, square rooting what this is on your calculator will give you the standard deviation. But I want to show you something. If you're using Excel, just to be careful here. See, the standard deviation is equal to, and this is the main part, right here, right on the bottom. For those who are doing general, you'll need to know the difference between these two. This is called a population number. So it's the number for the population. The problem with population is that you have to measure everyone in the state or in the population. It's too hard to get. So we do a sample instead. So if I wanted to carry a research, a sample is easy. I take only 100 students to represent millions of people. So that's called a sample. When you find the standard deviation, I'll show you on the Excel what it looks like. This is what it looks like on Excel. So I did exactly what you guys got. I put in the data, 468. I found the mean. Here's the mean. 4, take away the mean. We've got that. Here's your squared, and that's your value, right? Watch what happens when you do 8 divided by 3. So 3 numbers. Can you see the standard deviation here says 2? Right there. If you type in Excel to find standard deviation, I gave you the notes here. Have a look at the notes. If you type on Excel this, equals STDEV. So for those who are doing Excel, equals STDEV, brackets of your calculation. So 468. It will give you number 2. See that? Number 2. But if you do the calculation, thanks boys. I'm trying to highlight a difference here. So Jasper, just one thing here, just mainly for you guys. So if you're doing Excel, which if you type in the formula, which I'll show you again, it's STDEV. Okay, and I'm just doing 468 STDEV. If you do that on Excel, you get 2. But if you use the formula that I've given to you here and calculate it, you're not going to get 2. You're actually going to get 1.63. So you might say, why is it different? The reason why, and for the general students mainly, the reason why it's different is because you don't have a population of 3. You only got a sample. You're meant to divide it by n minus 1, and that's how you get 2. Why n minus 1? That's a theoretical one for specialist students to know. For general students, you need to know the difference between these two. One's population, one's sample. Okay, so if you're doing general, you might learn one of the two. So you need to know one is sample, one is population. That's why the calculations don't fit. Okay, so if you're doing Excel, just be careful with that. So what do you write as part of your notes? Right here. On Excel, answer is different. Make sure formula. This formula here, sum x minus x bar squared divided by n. Right here, change to n minus 1. Write that in. So this is for sample. So if you're wondering why the Excel the Excel answer is different. Population? Why is the Excel answer different to the calculation? If you do the calculation formula, the reason why it's different is because the Excel is calculating for population, sample population. Okay, so if you need to change it, make sure to change it to n-1, then it works. Okay? All right. For now, year 11s, you can continue on with with the exercise I've chosen for you. For year 12s, here's the last one. I want you to look at this graph. So at your end of year, you do need to know how to do this one. So I might put this on a sack. Here we go. Percentage cumulative frequency table. I filled out most of the data for you, but I wanted to know if you know how to find percentages and if you know how to read that graph. Here we go. Let's start off with Billy. So we've got frequency, which you've learned how to do with Mr. Hill, I assume. So you got data. How many 3s do we have? We've got 3. How many 4s? We've got 5. How many 5s? We've got 7. How many 6s? We've got 10. Pretty straightforward, yeah? All right. What is cumulative? Cumulative means that you start off with 3, then you gained another 5. So there's now 8 data in total. Then you gain another 7. So it's plus 7. Good. This is plus 5. And this is plus 10. And then plus 25. Because that's 0. Sorry, plus 0. And that's why you get 30. Now, if you add all of this together, it should also equal to 30. So far, so good? Okay, but this is the question. The question is, how do you find percentages again? So now you know cumulative is 3. The total is 30. What's the percentage? And how do you do that?
Well, obviously, 3 out of 30 is 10%. That's pretty obvious. But for the rest of them, you just got to find out, well, like what's already there. So 7 out of 30 would be 23%.
Yeah. Oh, okay. I see what you're doing.
Well, that's just how I do it. I don't know. Like, how would you work it out?
I got you. Okay.
That's how I do it.
No, you're right. I'm going to clarify difference here. So all year 12s. Thanks. Pav, Finita, I'm going to get you to pay attention here because this is probably going to be key. When you're doing cumulative frequency, which is different to what you were sort of just saying just now, when you have, likely what you did was you got frequency, which is here, and you said 3, there's 3 3s, and you said 3 out of 30, and you type on the calculator, times by 100, that's how you get your percentage of 10%, okay? This is called percentage frequency, okay? So you did that in chapter 5. Chapter 6, slightly different for this one, for all year 12s here, by the way. Cumulative, when they say percentage cumulative frequency, be careful. Cumulative means that it always keeps adding. So this is your 0%. That's why you started off. And you end up here, that has to be 100%. That's the difference about cumulative versus this percentage. So instead of doing this now, what they want you to do instead is to find the cumulative percentage over here. So not this one. So not 3, not this 3, and not this 5, not this 7. You're not doing that. Okay, that's then called percentage frequency. So make sure you understand the difference between them. This is percentage frequency. This one is percentage cumulative frequency. So what is the difference? This is what Billy was saying before. So for this one, he would have said 5 out of 30 times 100. But to get this 27%, it's actually 8 out of 30 times 100%. Get me? Because one is cumulative. Because what you end up getting is the percentages increase, and that's what this graph is representing. Why is cumulative frequency graph so good? Is because you can look at this graph, and I can ask you where the median is. See, the median is the 50th percent. Because it's cumulative, that means it's ranked 0 to the maximum. So the minimum is 10%, maximum is 100%. The median is where 50 is. So if you look at 50, median's 5. Get me? So that's why cumulative frequency is special. Okay, so when you're trying to find the percentages, don't make the mistake, which is what most students do in the exam. They use this one. It's not that one. That's frequency percentage. When they say cumulative frequency, you use this one. Okay, so here we go. I'm going to show you on the table so you can see. So don't use this one. Okay, don't use frequency. Use the cumulative frequency table. So here we go. I'm going to type in the formula. Equals 2C3 divided by 30, because we know the total is 30, and then times by 100. Well, what's going on there? Oh, it's already in percentage, is it? What does that give me? Oh, 10%. All right. Here we go. If I pull it all the way down, fill in the percentage. See how I got 27? The 27 is because I'm doing 8 divided by 30, then times 100. There's a difference between them. And that's why when you look at the graph, can you see how it's steadily growing? Because that's saying you started off at 10%. That's the smallest one you got. Maximum is 100%. And it keeps growing. But if you do percentages, it can go up and down. So they're not interested in frequency percentage. They're interested in frequency cumulative percentage. Okay, so percentage of the cumulative frequency. So you're going to do it this one. Notice the percentages, they increase. There's 10, 27, 50, 83. Why is 83 and 83 repeated?
Because there's no increase.
Why is there no increase? How do we know?
On the graph, it's 0.
That's right. See that? So right here, we got up, how many sixes? We had 10 of them. By the time you got to 7, there was nothing. So there was no increase because you didn't get any extra data. So that's why it stayed 25 and 25, therefore 83 and 83%. It wasn't until you got the last 5 data, that's how you get 100%. Now, cumulative frequency is just that slight difference. So why is it special? Because if I asked you now to find median, you know the median is the middle. So 50th percent, the middle must be, Q2 must be 5. Now, if I asked you to find IQR just looking at that graph, so that could be an exam question, they can chuck this in and they say, which one is IQR, or what is the IQR? If you had to estimate it now, remember, IQR, you told me before, was Q3 minus Q1. What's Q3 again? For U12s.
Q1
What's Q3?
is
75th. So you're looking for, where's 75th percentile? 75 is roughly here. So if we drew it across, it's roughly there. And then all the way down. Well, that's a bit off there, but it's roughly, say 5.8, 5.9. Something like that. 78, 75, and then minus Q1. If you look at 25, 25 is roughly there. Probably a bit, no, actually, it's probably exactly, yeah, it's pretty close. Yeah, it's probably 4. So Q1 is roughly 4. So if you put it together, it's 5.8 minus 4, roughly. So if you had to estimate the IQR, why is cumulative frequency graph great? Because it actually tells you the percentage from smallest to largest. If you just drew a frequency graph, you don't get the smallest to largest in ranking. That's why. Okay, so that's only for Year 12s. Year 11s don't do the cumulative frequency. For Year 12s, that to me is very examinable. Not standard deviation, but definitely this one. Okay? Sorry, team, that was a very long session because it is very theoretical.